We're going to go ahead and start day one of the predicting chemical reactions inquiry. Not sure this may take 2 or 3 days. This is going to be a criterion C activity, and eventually we're going to write our CER statement at the end of this and turn it in. The forms that you're going to need will be this one right here. This is predicting the reaction template. That's one I'd like you to open up, make a copy for yourself, and that's what you're eventually going to turn in. I'm going to go ahead and give you a little bit of a lecture, and we're going to start off with a prediction like we always do. And then we're going to go ahead and do a lab. And the purpose of the lab is we're going to see if we can predict what the products are of 4 different reactions. Now, we're obviously not going to do those labs. So I have 4 videos that I've set up for you here. I'm going to show you one of them to at least get you started, and then have you do the other 3 yourself. So why don't you start off by opening up this form here. This is the predicting products here. Make this one a little bigger so you can see it here. And then I'm going to go ahead and give you a little bit of information. So if you just fill out your name, date, and period on here, it's going to be a criterion C here. And we're going to start off with a prediction. But before we do that, let's go back here. I just want to bring up my lecture material here. You can follow this along at your own pace or make a few notes here. So we're going to start off with a scenario, and it's about air pollution, which I've already mentioned to you. There's 2 types of air pollution, those that go directly in the air, which we call primary pollutants, and then those which mix with things in the air to form secondary pollutants. So sulfur dioxide and nitrogen oxides are gases that are released into the atmosphere. Those are primary. And then they form with other things, a chemical reaction. They form acids, sulfuric acid and nitric acid. And these are what are involved in acid rain. And so we're going to start off here with a scenario about our own state capitol in Salem. So this is the Capitol building right here. It is made of calcium carbonate. What will happen to this big building here if we continue to pollute the air? So let's go back here to our form here. So we're going to go ahead and take calcium carbonate. Was that what they told us here? Calcium carbonate, yes. And we're going to mix it with acids, sulfuric acid and nitric acid. Well, the first thing we want to do here is we want to predict what type of reaction that might be. Let's remind ourselves, what are the types of reactions? And so, remember, we have learned that there are 5 types: synthesis, decomposition, single replacement, double replacement, and combustion. So once again, we're going to take calcium carbonate and we're going to combine it with an acid. So we're putting 2 things together, right? So let's go ahead and take a guess. Which one do you think it might be here? And again, there's no wrong guesses. It's just our starting point here. And what do you think might be the products of that reaction? Okay, once again, probably you don't have much of a good idea. This is a real guess at this point. What do you think would happen to the Capitol building as it was mixed with more and more acid? So that's probably an easy part. Okay. This is just a starting point. Don't worry if you don't have good guesses at this point. Now, we're going to go ahead and learn how to tell if a chemical reaction has taken place. So there are signs of a chemical reaction. We're looking for changes. What might happen? Well, you might see a color change here. You might see a gas formed. You might see a change of temperature. Sometimes it gets really hot. Sometimes it gets cold. You might see a change in pH. You might see a change of matter. Maybe it's a liquid, gas, I already said it. Maybe it's a solid, and when a solid comes up, we call that precipitation. And sometimes you see very dramatic things happen. Sometimes you see all sorts of light shoot out of it, or smoke, or an explosion, right? Definitely information that might indicate it's a chemical reaction. And sometimes you actually see a change of matter. Now, I know I've been telling you that conservation of matter says the reactants should equal the mass of the products. That is true, but sometimes it might combine with things from the air, like oxygen, And so you actually might get a larger mass in there. So what we're going to do here is we're going to try and predict the products of chemical reactions by looking for observations, then figuring out which of the 5 types of reactions it might be, and then we can go ahead and try and figure out what the products are. Just a little hint here as we go along. So one of the things we're going to work on today is identifying gases. You will see some gases in the reactions I'm about to show you. The 3 most likely gases are hydrogen, which is explosive, so it makes a popping noise. Oxygen, which is involved combustion, so it'll light up a flame. And carbon dioxide, which is actually the opposite, which puts out a flame. Hey, I might mention a 4th one here, water vapor. I guess that's a gas. So we're going to look for droplets that appear. I'm going to do one together with you, and then I'm going to ask you to do the other 3. What I'd like you to do is watch the reaction and make some observations. That's our goal for today. So let's take a look at the reactions we're going to do. These are the 4 here. The first one is going to be heating baking soda. So let's take a look at our form here. That's the first one we're going to do here. Now here's the procedure for it. Obviously we're not going to do this reaction, so we're just going to quickly watch the video here, and then we're going to make some observations. So let's click on the first one here. Okay. Hey, in this demonstration here, we're going to see what happens when we take sodium carbonate, or baking soda, and put it into a test tube like this, and we're applying a flame at the bottom there with a Bunsen burner. So you can see that it's not really melting. The salt is still there, or some kind of new salt is being produced. But you can see that there's water vapor which is appearing on the top there. So I'm assuming that H2O water is one of the products. So far we have some sort of salt being produced and some sort of water vapor. Is there any gas being produced out of here? Well, let's see if there's carbon dioxide. So we take a lit flint and put it in there. Now carbon dioxide will put out the flame if it's in there. So let's see what happens. Ah, the match went out. See, if it was oxygen, it would really light up. But carbon dioxide tends to extinguish things, puts out the flame. Let's look at it one more time. Let's see, let's get that flame in there. There it is, and it goes out. So now we know that water and carbon dioxide were definitely 2 of the products being produced in there. Okay, that's our first one. Let's go back to our form here now, and let's take a look and see if we can predict what must have happened here. So on our first one here, we're going to go down here, and this is our goal for today, day number 1. We're going to do qualitative data. What are the signs that a chemical reaction took place? All you're going to do is make observations today. So let's fill it out here. So what did we see? We saw water vapor, right? We saw that there must have been carbon dioxide in there. And we also saw that all of that starting material, which was sodium bicarbonate, you know, it didn't really just melt and go away, or it didn't vaporize. There was something left over. So there was some salt that was not melting. So we saw that there may have been 3 different products there coming out of there from our observations. Okay, your goal today is to look at the other 3 videos and simply to write down your observations like I did. Now think about what might be observations telling us a chemical reaction has taken place. And once you have those observations down here, that's going to be day 1. And then we're going to come back next time, and we're going to try and figure out what type of reaction it was of the 5, and then we can figure out what the products were. So that's going to be our strategy.